Namaskar, hello, and welcome to NCRT's live phone-in program. My name is Tanvi Khurana, and here in this session of Teaching Learning Interventions for Inclusive Classroom, we are going to learn science. Well, science we all know is the broadest topic ever, and under this category, science, we're going to learn something. What is it? You'll get to know from our expert, and we're going to meet the expert very, very soon. But before that, let me just tell you, if you are watching us on PM eVidya channel number 9 and 10, this session is for you. All the ninth class and 10th class students, this session is going to be very, very interesting for all of you. And you're also watching us live on our YouTube channel, ncertofficial. If in case there are any questions, any queries in your mind, then please share it with us. And you can write those questions in the live chat box, submit it to us. That's all you need to do. If you want to share those questions through email, then dth.class9@ciet.nic.in is the email ID. And also dth.class10@ciet.nic.in. All right, you can see on your screens that we have a sign language interpreter, and she is Miss Manisha Sharma. Hello, Manisha. Welcome, ma'am. And we have an expert with us who will be teaching us the science, and she is Mrs. Anima. Welcome, ma'am.
Good afternoon.
Good afternoon to you too. Ma'am is TGT Science, and she is an inclusive expert. So let's just ask her that what is it that we are going to learn in this particular session, ma'am?
Good afternoon, everyone. Today, basically, we are going to see a chapter from science that is matter around us pure? There is always a question that the things that we see around, are they impure or impure? But in case of science, we don't have any word called impure. It is either a pure substance or a mixture. So today our highlight would be that we would be learning things more about what are the different kinds of mixtures and what are their properties. Okay. So we already know that all matter is classified as pure substance or as a mixture based on its composition. So our basic highlight is that composition actually explains whether a substance is a pure substance or a mixture. Matter, as I told you, has been categorized into two basic parts. The pure substance, which again further is named as elements and compound. Whereas when it comes to mixtures, it is homogeneous mixture and heterogeneous mixture. Now, the question is, since we are focusing more into the mixtures, let's learn more about what are the different kinds of mixtures and what are the different characteristics or properties of mixture. Now, you see, mixture, when it comes to pure substance, one kind of entity. There are only one kind of things that are present. So when you have one kind of things, you cannot separate one from the other. Whereas when it comes to mixture, basically it is a physical combination of two or more different kinds of substances. So the moment there is two or more different kinds of substances, that thing becomes more interesting, and which is further categorized or named as homogeneous mixture and heterogeneous mixture. Now, you would be wondering, what is this homogeneous mixture? What is this heterogeneous mixture? Because these terms are very new to you. Homogeneous mixtures are such kind of mixtures that when you see them, you will not be able to distinguish the different phases that are there. They just look visually absolutely same. Okay, their composition of the components are uniformly distributed. But in heterogeneous mixture, the components are visible. There will be two or more different kind of components which will make a heterogeneous mixture, and the components will be visible to us. So that is the basic difference between a homogeneous mixture and heterogeneous mixture. Rather, if I want to explain you in a further way, in a very simple language, then homogeneous mixtures are those that have identical properties throughout. There will be no change of color or taste. They're just going to look and behave as if they are only one. So you find like salt water, gravy, whipped meal, cream, they absolutely taste and look same. So they are basically homogeneous mixture. Whereas heterogeneous mixtures are that part of the matter, that part of mixture of matter that has part with different kind of properties. Okay, now that becomes an interesting part for us, that mixtures, because they are made up of two or more different kinds of substances, and in homogeneous they have uniform distribution, in heterogeneous they have non-uniform distribution. So because we have two or more different kinds of components mixed together, then it becomes important for us to understand that how we are going to separate it and learn their characteristics or properties in a better way. So here again, homogeneous mixture, we already know that matter have pure substance, and then we have got the mixtures. Mixtures are again divided into homogeneous and heterogeneous, but that is not the end. Homogeneous solution is an example of homogeneous mixture. Salt solution, sugar solution, all these solutions are examples of homogeneous mixture. But heterogeneous mixture, again, there are variations. There can be suspension and colloid. So you are introduced to some heavy terms like suspension, colloids, and solution. That is where the thing becomes more interesting. Now I have got a small activity which you can perform it at home with the things that are easily available, and you can understand their properties in a better way. Now, instead of me telling you what are the properties, you yourself will be able to interpret and understand the different properties of these mixtures. Now, what do I have? There's a surprise for you, and that is that I have got 3 glasses labeled A, B, and C. These are simple glasses that you have at home. Fine. Now, I have labeled them as A, B, and C just to differentiate. And each of these glasses are filled with water. I have filled each of the glasses with equal amount of water. Fine. Now, what else do I have? I have to make a mixture. Now, these are what? This is water. This is not a mixture. To make a mixture, I have got 3 more things. What do I have? Please go and get a little bit of salt from the kitchen, which is easily available. Then I have milk, the milk that some of you love. And I also have some garden soil. Okay, I also have some garden soil. Okay, I got it from the flower pots that you must be having at home. All right, so what am I going to do? I'm going to prepare some mixtures. What do? I have taken salt. I have salt in the bowl. I take a small amount of salt and then add it to the beaker, to the glass A. So what am I doing? I'm making a mixture. Remember, I've made a mixture. Okay, I made mixture, and this is salt and water. So it is a mixture because there are 2 components, salt and water. Okay, fine. Next mixture, I'll take a small amount of milk in the spoon, and I'm adding to it. Can you see the color has changed, right? So this is our glass B, and then we have the 3rd glass of water. And what do? I had some soil and I mix it. Okay, I hope your mummy is not going to be annoyed with you, but just tell her that you are just doing an experiment. Okay, so I have got all these 3 different kinds of mixtures. This is what? Salt in water. This, milk in water. Little bit of milk, a few drops of milk in water. And this is soil in water. Now there comes the interesting part of it. I have taken a piece of paper and made a black dot on it. Now you have to tell me, what do you observe? The first thing, can you observe the black spot?
Yes, ma'am, very clearly.
Yes, okay. So Tanvi ma'am said that you can see. All right. Next, glass B. Can you see a little bit partially?
Yes. Partially, as in very, very
Yes,
light.
not pink, right? Okay, good. And then I have the third one. And let me see if ma'am can see. Can you see anything?
Not at all.
Not at all. So we have already learned a property. You know what we learned a property? This is basically, I made a solution. And you can see a solution is a homogeneous mixture. So homogeneous mixture solution is transparent because you can clearly see the dot. Clearly, it's easily visible. So it is transparent. What is the scientific name? Transparent. You already know that if something you can see it clearly, then we call it as transparent. In the second one, where I took milk in water, this is also a kind of mixture and it is a heterogeneous mixture. Okay. And we call this mixture a colloidal mixture, colloidal solution, where the dot is partially visible. So what is the other name of partial visibility? We call it as translucent, partially, lightly visible, not clear, but partially visible. Whereas in the third one, when I had placed the paper, you could not see the dot at all. That means it is completely blocking the black mark, which is named as opaque. So we already learned one property that solution is transparent, colloid is translucent or partially visible, whereas in case of a suspension, it is opaque. Right? So we already learned one property. So you are learning by seeing as well as you are performing it with. All right. Let's go to the second part of it. We learned one property, that whether you are able to see or not. The second property is whether you will be able to filter it or not. You want to separate the mixture, right? You don't want the salt in water, or you want to separate the milk. Let's see if you can separate the salt from water. So what you need to do is, I've taken a tea strainer and a filter paper. Tea strainer and filter paper, and I'm going to filter it. I'm just trying to see if I'm able to separate it or not. So I'll just take the glass and pour a little bit of salt solution. Fine. Now what happens after I poured, if you look into the filter paper, you will find that there is no salt. So, but you added salt, didn't you?
Yes.
We all added salt, but where did it go? That means this filter paper could not stop the salt. The salt has actually gone into the other glass. So it sneaked away. Chupke se bhag gaya to the next glass. Okay. So you see, you are not able to separate salt from the solution. First observation. Let's go to the next one. Can I separate milk from water? Again, what do? I'm taking this and filtering it. I've just filtered it. Now, again, the milk also sneaked out. It did not want to remain on the filter paper. It did not want to show its presence. So this also sneaked out. All right, fine. Let's see what happens with this. In the third one, when I take sand, when I take the soil, let's see what happens in this case. In this case, interestingly, that we find some remains of the garden soil, some remains, trace amount. That means you will be able to filter a suspension, but you will not be able to filter a colloid or a solution. So this is the second property that you have learned. Solution and colloids cannot be separated by simple filtration method. There are other methods, okay, but not by this filtration method. But this suspension can be separated by the filtration method. Now let me do a third magic. It's very interesting. Okay, I've got a laser light. Okay, now just tell me whether I'm glowing the laser light or not. Can you see anything inside the glass?
Yes, yes. The red light I can see.
Yes, but then you cannot see the path. Can you? Not possible. Let's see whether you can see the path here
Clearly.
clearly. Okay. So you already caught the thief. And what about this?
Oh, and the color changed.
Yes, so it's absolutely, that means the pathway is clearly visible. So this is another property that we have learned, that light, the scattering of light, the pathway of light is easily not visible with solution, but it is visible through a colloid and suspension. So these are small activities by which you can actually learn their properties as well as differentiate them. So today I've just done three properties which are very easy. One is whether it is transparency. We saw solution is transparent, colloid is translucent, whereas a suspension is opaque. Fine. In the second one, when I tried to filter, I saw the salt sneaked into the filtrate. Separation is not possible at all. I tried to separate this milk from water, which is a colloidal solution. That also I could not separate. I failed to do that. That means colloid and solution cannot be separated by using a filter paper. Please understand, by simple filter paper. But I could separate successfully. I can separate soil from suspension. That is possible. And we did the third magic. We caught the thief, that when light was passing through a solution, I could not see the pathway. But when it was passing through the colloid, it showed its presence. And when it was passing through a suspension, clearly the light thief was caught. That means the scattering of the pathway of light is visible through a colloid and suspension, but not through a solution. So you see, such a simple activity actually explains the different kinds of mixtures that we have in and around us. And salt solution, then milk, soil and water, these are common type of mixtures that we come across every day in our day-to-day life, but we had never tried to analyze their properties in this manner. We all knew it. When you see that knowledge of suspension being separable by filtration is clearly understood when you make a cup of tea. That's how you use a strainer, right? But you will never try to strain a cup of coffee because you know that it will not be able to separate. So we have those knowledge. Only thing is we are unable to identify them. So today we had learned some important properties of the mixtures, that is homogeneous mixture, solution, and heterogeneous mixture, that is colloidal suspension. Okay. So if we just go through the size, you know why I could not separate the solution and colloid? Because the size of the colloid and solution particles are very small. Look at them. Size is less than 1 nanometer. It's so tiny that it passes by. That filter paper could not stop it. So because of the size being too small, but suspension, it's a huge hefty fellow. Huh? It's greater than 100 nanometer. So it gets caught by the filter paper.
Okay. That's why. Can you mention a few? Take the salt out of the water, or maybe milk out of the water?
Yeah, basically when it comes to solution, there are other methods, like filtration is one criteria with which you cannot separate a solution. But evaporation, what about evaporation? When you evaporate salt solution, then you will find water will get evaporated and salt will be left behind. So that is one way. We also have another method that is known as crystallization, which children will gradually learn, whereby that possibility of the salt from water is possible. Right?
Okay.
Next, yes.
One more thing, like suspension. Even through filtration, you were able to separate soil from water. So once the entire soil gets drained out in filter, will we get the water the way it was, or some particles will be left?
There is possibility. You know what? The basically suspension, the soil that I had taken, they were of various sizes, right? So it will look absolutely clear and clean, but definitely I'll not suggest it to be poured back into your drinking bottle and then to sip it in. That may not be possible. Maybe microscopic level we might see some particles, but then factually in a macroscopic level, we will be able to separate the larger particles which were greater than 100 nanometers. All right. Beyond that, if it was smaller than that, then that can also sneak out and get into the filtrate. So it will not be as pure or completely in the same state as it was before, but somewhat we might be successful to 95-96%, depending on the size of the particle of the suspension.
Okay. Okay.
And so if we have to categorize, this is in a tabular form, like whatever we had learned, if we have to put it in a table, in that way, it is giving you two things. One is it is helping you to differentiate the different kinds of mixtures. Second is individually also you will be able to understand the properties of matter. Like for example, the particle size, we know that solution size is less than 1 nanometer. That's why we are unable to filter it. Colloidal solution size is around 1 nanometer to 100 nanometer. So, you know, it is in between. So you are unable to separate it by filtration method, but of course by centrifugation. So here, Tanvi ma'am, I would like to mention that colloidal solution cannot be separated by filter paper, but can be separated by a process that we call it as centrifugation. Let me give you an example of centrifugation. Makhan, how they churn the milk and get butter out of it,
yes.
Right? So that is a centrifugation method. So because milk is a colloid. Okay? If you want to filter it, if you want to separate the components with the help of filtration, not possible. But centrifugation, of course, it is possible. Right? Then comes suspension, that it is more than 100 nanometers. So that's how you are able to filter it. What is the state? Now, when it comes to state means whether it is stable or unstable. I would just like to again see this was solution. Whatever was the color before and after is absolutely the same. Now, what happens in this case, if you see beaker A, B, and C, these three glasses, you will find that water, for instance, if I just take salt solution, I just leave it aside. Colloidal solution, I'm just turning it, and this one I'm just turning it. Just see. If I just wait for some time, I find that there is no change. I don't find any sediment being formed at the center. That means salt is not settling down. So it is stable. Before, the moment you added whatever was its state, it is still the same. So it is a stable mixture. But when it comes to colloid again, you don't find any milk particles settling down. So it is also stable. But what about suspension? You know, if I keep it, you find that the soil is settling down and the other parts are becoming lighter. So as I keep it, you will find that there is sedimentation which will happen. And this actually explains that it is unstable. It's very unstable. It was something when I dissolved it, when I tried to dissolve it, and it has become something when I had left it aside. That's how it means the suspension is unstable, whereas true solution and colloid are stable. Tyndall effect is the light that, you know, the thief light that was trying to pass. So true solution, we could not track the path, but colloidal and suspension, you could actually see the path. So that is a scientific term that is used, which we call it as Tyndall effect.
Okay.
So please note the spelling, Tyndall, Tyndall effect. Yes, Tanvi ma'am.
Okay. If we talk about the need, like you mixed those three things and then you try to separate those three things. What is the need to separate them? Why can't we just let them be?
You know, that's a very interesting thing, that why do we actually go for separation? Yes. Separation has many reasons why we do it. Because all the components that are there in a mixture may not be useful to us. Now, for instance, if you're making rice or dal, you might have some unwanted particles there, some small pebbles, stones, husk. So you need to separate it in order to make it fit for consumption, right? So separation is done with different objective. Maybe we separate it in order to separate the unwanted things from the wanted things. Or you may be separating things in order to use the components in a different way. Like for instance, if I'm churning the milk, okay? Once I churn the milk, I get butter and buttermilk. So I want to have buttermilk. That I cannot have it if I take milk as a whole. So I have to do the separation by the help of this centrifugation method. All right. So these are some of the reasons why separation is done. And also sometimes that once the the need of one component is completed, then we want to remove it, like while making a cup of tea. Once the tea is used for making a cup of tea, it has given the color and flavor, we wanted to say goodbye. So that's how the reason why we do the separation. So
Okay.
there are different reasons why we go for separation, and it really helps us in understand. And another thing that I need to mention, until and unless you don't know the difference of properties, you will not be able to separate them.
Okay, all right. If we talk about the children with special needs here, because we are here talking about the inclusive classroom, we can't separate the children with special needs. They're a very important part. So, do they enjoy science? Do they run away from these experiments, or do they take a lot of interest? What exactly is their perspective?
Uh, I tell you that science, when you do it, and when you are learning by doing and seeing, that really makes it very interesting. And children with special needs are no different from the normal lot. They're absolutely, they also enjoy over the more because they find themselves included, involved, and they are able to interpret the observation. So,
Okay.
for instance, it's a surprise for them that, like, it depends on how you are introducing it to the class. So, if you say, okay, let's find the path of the light that I tried to do with a laser beam, they say, no, you cannot. Then they said, yes, I caught the pathway. So, in that way, they observe and they understand. So, what happens in case of science is a subject where you learn the concept in a better way when you are doing and seeing it. So children with special needs take a lot of interest, particularly in things where they are involved in such experimentation, when they are able to correlate with the things that are in and around them, where they can actually identify that, yes, these things actually happens in our surrounding, and now I know it, and they will never be able to forget about it. And in fact, this is what we had observed over the years, that when such kind of small experimentation very correlated to the environment is performed in the class, and particularly with children with special need, they really are enthusiastic, and we are successful in imparting the knowledge and teaching to them in a better way when we do such kind of experimentation. So it
So
really
you,
helps to.
you being an inclusion expert, you always encourage students.
Of course, it has been always a privilege to work with children of such kinds. Of course, they all have individual challenges, but we tried to modify things so that we can just make it as simple as possible in different ways. Like wherever there is a scope of such kind of experimentation, we do try to introduce such kind of things. Or if it is quite a factual and theoretical, then maybe some kind of flow chart, some kind of diagrammatic explanation. Of course, that really helps.
Wonderful. Okay, ma'am, we've got last couple of minutes left. So I have one last question, and try and keep the answer a little brief.
Yeah.
So if we talk about air, we can see it's transparent. We can't see air. So can we say that it's a pure substance?
Air is basically a mixture. It
Really?
is not. It is not only one substance. It is basically a mixture because it is. It has got different gases. Composition of air. You have got nitrogen 78%, oxygen 21%, carbon dioxide, water vapor, and you also have different kinds of particulate nature, particulates, and different kinds of gases. So it is a mixture. They don't have a physical. So it is because it is a mixture. That's how when we inhale everything, it is only that oxygen that gets into our system, and it is only possible when had if it was not a mixture, then that segregation would not have been possible. As I told you, separation is possible only when things are mixture or their properties are different from one another. So air is a mixture, it is not a pure substance.
Absolutely. That's some new information. Thank you so much for being with us and for this experiment in particular, because it was amazing the way you showed. With experiments, we tend to, have more interest in science. Thank you so much.
Thank you.
Thank you, Manisha, to you too as well for all the science you did to our students, to our viewers who are watching this session. Thank you. Thank you to all the students as well. You saw this session, and I'm expecting that you liked it. If you have any questions, then please feel free to reach out to us and write it down in the chat box of our YouTube channel, NCERT Official. We always welcome your questions, your queries. Um, we'll take a sign off here, but let me tell you that tomorrow, same time, that is 12 o'clock, we'll come back again with a new topic that'll be peer support. And that will be for 11th and 12th class students. So you can join again on PM eVidya channel number 11 and 12. So I'll meet you tomorrow. And if you have any questions, like I said, please share. Stay safe, stay protected, stay in your own houses. Thank you so much. Namaste.